This lesson is on numerical methods and the Simpson rule. Simpson's rule is a method used for numerical integration. That is, it's used to approximate the area under a curve. It is very similar to the trapezium rule, except it's far more accurate. So here it is. Simpson's rule is defined as, if we have the integral I equal to the integral from a to b for some function that y is equal to, then it is equal to this here. And you'll notice it's very similar to the idea that we've used in the trapezium rule. This is used where n is the number of strips, which is always even, and h is calculated by b minus a over the number of strips. So let's have a look at an example. It says, use Simpson's rule with 4 strips to find an estimate for the integral below, collect to 3 decimal places. So we have the integral between 1 and 2 for the square root of 3 plus x cubed. Okay, so in this question we have the integral, we have Simpson's rule. We are told that the number of strips we require is 4, so n equals 4. And just like the trapezium rule, first of all we want to calculate the interval width. So I'm going to do the upper boundary, which is 2, minus the lower boundary, which is 1, divided by the number of strips, which is 4. So h equals a quarter. And I'm just going to say, for argument's sake, for ease, it's equal to 0.25 as well. So both values are of benefit in this question. So we're going to do a table now. In a table we're going to have x values, and so we're then going to also have y values, and perhaps instead of putting x0 we should have here xn. So start off with the lower boundary and then we step up in steps of a quarter, so 1.25, 1.5, 1.75 and 2. In the question, it's asked us to work and give an answer to 3 decimal places. So that means that I'm going to store my answers during my work into a minimum of 4 decimal places. Usually I go one step further than this. So if I evaluate 1 in our function 3 plus 1 cubed, square root of 3 plus 1 cubed, I get an answer of 2. If I then evaluate the square root of 3 plus 1.25 cubed, we get 2.22556. If I evaluate the square root of 3 plus 1.5 cubed, I get 2.52488. If I evaluate the square root of 3 plus 1.75 cubed, I get 2.89126. And finally, if I evaluate the square root of 3 plus 2 cubed, I get 3.31662. So having evaluated and found the values of y that are going to go into Simpson's rule, I can now work out Simpson's rule. First of all, I state this algebraically just to make sure in my mind I know what's happening. So what I mean by this is I know that it's going to be I equals h over 3. It's going to be y0 plus my highest y value, so that's going to be 0, 1, 2, 3, 4. So this is going to be y4. N always matches the number of strips, notice. Plus 2 times the even values, so I got 0, 1, 2, 3, 4. It's only y2, so plus 2y2. And then plus 4 times the sum of the odd values, which is y1 and y3. So add y1, add y3. And there's a couple of reasons here why we start from 0. One, because the number of strips, the last n value will match the number of strips. Secondly, it's because the first term, 0, isn't an even term, or it wouldn't be an odd term, so we wouldn't want to be confused and get those included in these parts of the formula. So now I can actually substitute in the values. I get I equals h over 3, so in fact this is going to be 1/3 times 1/4, times y0, which is 2, plus y4, which is 3.31662, plus 2 lots of y2, which is 2.52488, plus 4 lots of odd terms, so I get 2.22556 plus 2.89126, and close off those brackets. Now, showing all the working at this stage, there's no more marks for showing any intermediate working. You should hopefully be confident enough to enter this into your calculator in one go. So if you want to do some intermediary steps just because you're not that confident, that's fine. But then the next mark is given actually just for evaluating this and finding that the value of this integral is approximated to be 2.569 to 3 decimal places. And notice my answer is then rounded to the correct accuracy. Okay, so there's an important note here. This was mentioned during numerical solution of equations. Calculus is always carried out during radians. So that's integration and differentiation. In other words, whenever we differentiate or integrate trigonometric functions, we must use radians. This means that you always use radians when using the Simpson rule, like you always use radians when using fixed point iteration, whenever a trigonometric function appears. Okay, if you convert angles to degrees, in either case, it is mathematically incorrect and you will be marked so in all cases. And what that means is you won't get the marks. Okay, well I hope that all made sense and that you was able to follow my solution.